Okay, let's take a look at exercise 2.2.5. Question is, consider a matrix, a 3 by 4 matrix A. Find the rank of A, a basis for the row space of A basis for the column space of A, and a basis for the null space of A. This was a big topic in section 2.2. The main reference, take a look at the notes, was note 2.2.A, which tells us how to find a basis for each of these spaces. So we'll take this matrix, A, we'll find a row echelon form of it and call it H. We'll find a reduced row echelon form because that is a row echelon form. And find a basis for the row space. Part 1, we'll use the non-zero rows of H. Find a basis for the column space. We'll use the columns of A corresponding to the columns of H, which contain pivots. In part 3, for basis of the null space, we'll solve the associated homogeneous equation, Hx equals 0. You've got lots of experience solving homogeneous equations and systems of equations, but actually that'll be the lengthiest part of it. So first thing we need to do is take matrix A and find a row echelon form. Let's put it in reduced row echelon form. Wolfram alpha will output this. Notice there's 3 pivots. There's pivots in the first 3 columns, and there's information in that. So let's address part B first. In part B, by note 2.2.A, so we're looking for now in part B basis for the row space of A. So basis for the row space, we'll use the non-zero rows of H. All rows of H are non-zero. So by note 2.2.A, a basis for the row space of A is the set consisting of the non-zero rows of H of which there are 3. We're finding a basis. Has 3 vectors in it. Must be a 3-dimensional space. So part B, there's a basis for the row space of A. Consists of those 3 vectors, 3-dimensional space. By the way, the vectors each have 4 components. So this is a 3-dimensional subspace of R4. Next, they want a basis for the column space of A. Well, note 2.2.A dealt with that as well. For a basis of the column space of A, we'll take, it said, the columns of A in positions corresponding to columns of H which contain pivots. The columns of H which contain pivots are the first 3, pivot-free column in the 4th one. So for a basis for the column space of A, we'll take the first 3 columns of A. So a basis for the column space is first 3 columns first 3 columns of matrix A, the original matrix. So that's a little oddball because sometimes you use matrix H, you use matrix H for the row space, you use matrix A for the column space. We skipped part A, but let's come back to that part now. And you might notice that the column space of A consists of vectors with 3 components. So the column space is a subspace of R3. The row space was a subspace of R4. And we're dealing with a 3 by 4 matrix. So the book's pretty much balanced on those dimensions. Now the rank of a matrix was the common dimension of the row space and the column space. So the rank of a matrix is the common dimension of its row and column spaces, its row space and its column space. So here, the rank of matrix A is the dimension of the row space, 3 vectors and a basis, the dimension of the column space, 3 vectors in a basis for the column space. Let's go to a second video and work the next part, the final part, a basis for the null space.